All right. Hi. So now that we went over the homework, which was the Newton's second laws of motion, what we're going to do is Newton's third law of motion now. And so if you turn to T and U in your packet, we're like almost done with this chapter. Woohoo! Um, what we need to talk about is just going to read this information here. So it says, a force is a push or pull upon an object. This implies there must be two objects, one being pushed and one doing the pushing. This is really important. Then it says, thus, forces result from interactions between objects. According to Newton's third law, whenever objects interact with each other, they exert forces upon each other. These forces are called action-reaction forces. Okay? So Newton's third law says every action has an equal and opposite reaction, okay? And so this can sometimes be confusing. Let me see if I can do this and then make it small again. Okay, so this can sometimes be confusing because you say, oh, okay, well, if you exert a force this way and it's 5 newtons, and then you exert a force this way and it's 5 newtons, then what should your net force be? Well, you would say that your net force was 0 if you were acting on the same exact object. And that's true. It would be 0. And so it wouldn't move. But what we're talking about in these scenarios on this packet there's movement, there's motion. There's a positive net force or an unbalanced force. And so we're seeing something a little different here. And the reason that is, and this is really, really important, and I would recommend maybe you put a star here, is because action reaction pairs act on different objects. Action reaction pairs act on different objects. And that's the key right there. Because if we had, like I was saying before, 5 newtons this way acting on this, and then 5 newtons this way acting on this, well, they're both acting on the same object. And so you would have a net force of 0. But with action-reaction force, we have something different because they're actually acting on different objects, which is really important. So let's look at this scenario. We have a man exerts a force on the refrigerator, and then the refrigerator exerts a force on the man. And so they're not exerting a force on the same exact thing, which is why you can have movement. This one is a horse pushes back on the ground and the ground pushes forward on the horse, which is why it's able to move. So what I want you to do is you can go ahead and pause this. I want you to spend a couple minutes. I want you to go ahead and try to answer questions 1 through 5. And then Ms. Paraska, you can just pause this, and then I'm going to come back and go over these answers. So just go ahead and pause this, and then we'll go over them. Okay, so let's go over these questions. So number 1, it says all forces result because of interactions between objects. And then it says forces come in pairs. What are those pairs called? They're called action reaction pairs. And then it says, here we go, label the reaction force with arrows. So here we have a man pushing up on a bar, and you should have the bar pushing down on the man. Here we have a ball pushing on a pin, and we need to have the pin pushing on the ball. And here we have air pushing on a balloon, and then we should have a balloon pushing on the air. All right, if we move over to question 4, this is acting weird. Sorry, not give you motion sickness there. Okay, we have in the drawing above, how much force is the physics student exerting on the rope? So the physics student is exerting 500 newtons this way on the rope, right? He's pulling as hard as he can, 500 newtons. How much force is the wall exerting on the rope? It is exerting 500 newtons to the right. What is the net force on the... Oh. How much force is a physics student? So the net force on the force gauge is 500 newtons. Would the physics student be moving? So based on what we have here, actually, I am not telling the truth. It's 250 newtons and 250 newtons. I'm sorry. Because this object right here is having 500 newtons pulled on it. So this wall is pulling this way 250 newtons, and this way 250 newtons. So it's feeling, okay, sorry. Will the physics student be moving? I would say no. What would happen if the wall stopped exerting a force? So what would happen? The boy would go flying. To the left. What happens if the physics student is standing on ice? What would happen? So less friction, the boy would move to the right, correct? What is the force between the student and the ground called? That's the force of friction. Draw and label arrows on the diagram to represent 3 sets of force pairs. So we could have let's do the boy's feet on the ground and the ground on the boy's feet. We can do the boy pulling on the rope and the rope pulling on the boy. And we can have the wall pulling on the rope and the rope pulling on the wall. The drawing below, draw at least 5 force pairs. Whoa. You could say the ground. Oh, sorry. And then the feet. You could say the string, the man and the string. You could say the ape and the string. You could say the ape or the string and this ape. You could say the tree and the string. So those would be 5. Okay, so what I want you to do for homework tonight is page V. So I'm going to upload that on Google Classroom. Page V is your homework. It shouldn't take you very long. I also have uploaded a video about Sir Isaac Newton. It's like an hour and a half long. It's actually kind of interesting about the type of man that he was. If you guys have time to watch it, I would give it a try. Tomorrow, we will do a wrap up of everything. Hopefully you guys are doing well. Hopefully I'll be back tomorrow. Bye.